Have you ever found yourself puzzled by parallelism in Apache Flink? You're not alone. Today we're diving into some common questions about setting parallelism in Flink, and I promise you, by the end of this video, you'll have a clearer understanding. I totally get it. Parallelism can be a tricky concept, especially when you're trying to optimize your data processing tasks. Many users have faced similar questions, and it's completely normal to seek clarity on this topic. Let's take a look at the specific questions that have come up. One user asked, does the set parallelism function apply to just the sum operation, or does it affect both flat map and sum? They also wondered if it's possible to set different parallelism levels for different operators, like setting parallelism to 5 for sum and 10 for flat map. Finally, they questioned how many threads would handle 10,000 partitions if set parallelism is set to 5. Sound familiar? Let's explore these questions together. To understand these questions, we need to clarify how parallelism works in Flink. When you set parallelism, it defines how many instances of an operator will run in parallel. This can significantly impact performance, especially in data-intensive applications. And stick around. I have some valuable insights at the end that will help you optimize your Flink applications even further. To address the user's first question, the set parallelism method applies to the entire operation chain. This means that when set parallelism is set to 5, it affects both the flat map and the sum operations. For the user's second question, yes, it is possible to set different parallelism levels for different operators. The user can achieve this by calling set parallelism on each operator individually. Now, regarding the user's third question about keyby and partitions, if there are 10,000 different key values, the number of threads handling those partitions depends on the parallelism set. If set parallelism is 5, only 5 threads will process the partitions. In summary, the user can control the parallelism of operations in Flink to optimize performance. By setting different levels for each operator and understanding how keyby works, they can effectively manage their data streams. Fun fact, the concept of parallel processing dates back to the 1960s. It's amazing how far we've come in optimizing data processing tasks. Now let's look at the answers provided by other users. An alternative approach shared by a user highlights the importance of the execution environment in Flink. They explain that the execution environment sets a default parallelism for all operators, which can be adjusted using the set parallelism method. This user also emphasizes that while the default parallelism applies to all operators, it can be overridden for specific operators if needed. This flexibility allows for tailored performance adjustments. Here's a pro tip. Always consider the nature of your data and the operations you're performing when setting parallelism. It can make a huge difference in performance. And there you have it. You now have a better understanding of parallelism in Flink. Remember, optimizing your parallelism settings can lead to significant performance improvements. If you found this video helpful, don't forget to subscribe for more insights and tips.